try to concentrate on what is meant by asymptotic. Asymptotic is a line in a graph which close to the curve. Asymptotic is a line in a graph which is close to the curve, but this line never touches the curve. Asymptotic line is a line which close to the curve, and which never touches the curve. As the distance between curve and line will become closer to infinity. So asymptotic is a line, this and this in this case, asymptotic is a line which close to the curve, and never touches. As it gets closer to the curve and go to infinity, closer to infinity, it will go on like this. Hope everyone understood, right? So we have a curve in a graph. This is curve, this is curve. Here we have one line, this is one line, and this is second line. If you observe, this line closest to the curve, close to this curve, this side also, this vertical line also, horizontal line also, very close to the curve, but these are not crossed. This line not touched this curve, right? This line we will call it as asymptote. This and this lines we will call it as this one. So I hope now you understood, right? Asymptotic is a line which close to the curve and never touches the curve as distance closer to infinity. This line goes on like this, and this line also goes on like this. This side also same thing. So in this way, this is vertical line, this is horizontal. Okay, so this is what the meaning of the definition of asymptotic. Because if you know this, it's very simple. It won't take much time also to understand the definition. But if we doesn't know what is meant by this asymptotic, even though we learn the great complexity notations or how complex it is, that will be not worthy enough. Okay, so now we understood what is the definition of this. So we will try to, now what we will do is, we will try to identify the vertical and horizontal lines, asymptotic lines for given function f of x. Okay, for given function f of x, so that it will be very much clearer, so that it will be good to learn also. Okay, so the first thing is, we can say f of x equals to 1 by x minus 3. For example, this is what the function of that curve. Okay, this is the function of that curve. Now the goal is to identify horizontal and vertical line of asymptote lines. So we will find the two lines, vertical line and horizontal line. Those lines will be very nearer to this curve, but never touches this curve. That is what we are going to identify. Okay, so as usual, first we will draw a graph. This is x, this is y-axis, right? Everyone knows. Now, to identify vertical and horizontal, this is numerator. Everyone knows, right? This is numerator, this is denominator. Yes, this is numerator and this is denominator. Here, if you observe, we can say 1 x0, right? x0. This will be x power 1 degree. Degree of numerator x0. We can represent, if you multiply with x0 with 1, 1 will only come. So just to understanding purpose, I have written x0. So if you observe here, in numerator we have 0 and in denominator we have 1, right? So that means this denominator is heavy. Denominator is very heavy. So in such type of scenarios, the horizontal asymptotic line will be always y equals to 0. So once again I am repeating, we have the function 1 by x3. So first what we done, we identified what is numerator and what is denominator, right? So after that what we done, we try to identify the degree of numerator and denominator. In this case, here there is 0, here x, we have 1x, we can represent it as x power 1, right? So our denominator has high value. So in this type of scenario, we can say the horizontal asymptotic line can be y equals to 0. Okay. So now we identified horizontal. Now what we will do, we have another line also. We can identify vertical line also. Whether how to identify? Let's see. See here, the denominator is x plus 3, right? X plus 3. So we always make it as equals to 0. Okay. To simplify x, to know the x, what we can do? We can add minus 3 here and minus 3 here. I am adding both sides. So what will happen? This 3 will be gone. So now I have x equals to minus 3. Right? So this x equals to minus 3 is our vertical line. So this is our horizontal line. So these two lines always never touches this curve. So until unless except for these values, minus 3 and 0, right? Hope everyone understand, right? So now we will try to plot this. Now I will erase this. So now we know y equals to 0 and x equals to what? Minus 3, right? So now I will erase this. Now let's imagine this will be 0, right? 0, 1, 2, 3, 4, 5. Go on. 1, 2, 3, 4, 5. Goes on. So here it will be minus 1, minus 2, minus 3 goes on. Minus 1, minus 2, minus 3. It will goes on. Right? So now we know what is x. Our vertical limit is minus. It is minus 3. Right? Here it is there. Minus 1, minus 2, minus 3. So our vertical line will falls under this. Minus 3 and 0, right? It is minus 3. This is our vertical line. So anyway, y equals to 0 means this will become like this. This is the same way like this. The curve can be like this, or the curve can be like this. The curve can be like this. The curve can be like this. See, this type of curve can be possible once we place the proper order. Based on our input values, the curves can be placed here, placed here, placed here. But any curve, these curves never touches our vertical line and horizontal line, right? So this is one of the function example plus 5. This is another kind of one function, right? So to identify what is the vertical and horizontal, we can do same thing. First we will try to identify horizontal. Horizontal means slant. So as we already know this value, because this degree is 1, this degree is 0, so this will become as 0, y equals to 0, plus we have another term here, so that we need to represent. So y equals to 5. So y value will pass on. So for example, if we have graph here, the graph, if it is the graph, so 1, 2, 5 it is there. So our y value is 5. That means my line, horizontal line, goes on 5. So now we will we identified horizontal line. Now we will try to identify vertical. Vertical is same as previously what we exactly done. X plus 3 equals to 0. To simplify x, to calculate x, what we can do? Add minus 3 here and minus 3 here. These 3 will gone. So x equals to minus 3. So minus 3 here. So this is my vertical line. This is my vertical line. This is my horizontal line. So once you pass some values and if you try to plot, so the graph can be come here or come here or come here or can be here. But in any case, this curve or this curve or this curve or this curve never touches our vertical and horizontal asymptotic. But they will be very nearer. But they will be very closer. But they never cross. They never touch. So this is another kind of finding the values of asymptotic, horizontal and vertical. Now we will see another example so that it will be very good. So here, this is our numerator, this is our denominator. So if you see, the degree of numerator and degree of denominator are same. In this case 1 and this case 1. So we can't simply say that y equals to something, but we need to work on this. So if you observe here, we have some values, 16, 4. This is 16 and this is 14, 4. But really should we bother about these values or not? The case. So normally if you take any graph, right, this is what exactly means. We are saying a line closes to the curve but it never touches as the distance closes to infinity. So if you place instead of x some large amount of number, 2 lakhs or 5 lakhs, 1000 or whatever it is, in that scenario these are values are very less. These are we can ignore them, right? So what we will do is, to identify the vertical horizontal line, we will take this part. So 8x y equals to 8x divided by 2x. The value is 2, 8, have graph like this, the line will go from here. So now we know how to calculate our vertical line. Vertical line is simple. So 2x plus 4 is our denominator, equals to 0. So what will happen? Minus 4, we can add minus 4 here. This minus 4 will go. 2x equals to minus 4. X equals to minus 4 divided by 2. That means minus 2. So in our graph, minus 1, minus 2. So this is our vertical line. So minus 2 is my vertical line. 4 is my horizontal line. So the graph can goes like this, or goes like this, or goes like this, or goes like this, but these curve and lines never touches. That is what these lines. Now we will see another example. F of x equals to 5x square minus 1 x plus 3. Let's imagine. So if you observe here, this is numerator and this is denominator, and if we observe degree, here 2 is there, here 1 is there, right? So here in this case, the degree of numerator is greater than 2 is greater than 1. So in this case, we can't find horizontal. There is, for this graph, there is no horizontal line, right? We understood when numerator degree is more, then there will be no proper horizontal asymptote. Now we can find vertical asymptote. That we know already. We learned x plus 3 equals to 0. We can add minus 3 here, minus 3 here. So these 3 will go, x equals to minus 3. So for this graph, for this function, we have only minus 3 vertical line. But as we said, there will be another horizontal line that can be error prone or some bleached kind of thing. So now we understood the concept of what is meant by asymptotic, right? Right, everyone? Now I hope you enjoyed this explanation and understanding. I hope everyone you understand properly, because if you understand the word asymptotic, it will be good for you to learn the concept of what is meant by asymptotic notation. Without understanding what is the meaning of this word, it's not worthy enough to learn, right?